So good afternoon to Ellen and Dr. Robert Holcomb.
Good afternoon.
Hello there. Nice to see you.
Yeah, nice to see you. Yeah, it's nice that we come to this discussion and to the interview and to make the interview, because we will talk about energy and energy supply, energy savings in Europe. And my audience is the industry, and at the moment in Central Europe, nothing is more important for the industry than the energy supply. So we are really in the middle of the focus, yeah? And you have some answers to that. Huh?
We do.
We do indeed.
Yeah. So as we heard, it's with your system, it's possible to reduce the carbon footprint by 80%.
Yes.
And also the energy cost by 80%. Right. And also to save energy, because you don't have to cool generators. So there are a lot of advantages. We will come to that. And first, I would like you to introduce you a little bit. So you have spent a lot of time on this development, and then we go into the topics. Yeah.
My name's Ellen Holcomb. I'm the co-founder and co-owner of Holcomb Energy Systems, along with my husband, Robert. My background is not in engineering or physics. It's really in journalism. I was a journalist internationally for some 25 years, working for some major media outlets here in the United States. Holcomb,
I'm sorry. Yeah.
And I ended up going into public relations, and that's how I met Robert. And he was a client of my firm in New York City. We were announcing another breakthrough energy technology of Robert's. Really kind of the rest is history. That's how we met. That was some 18 years ago. We've dedicated the last 15 years to really bringing this technology to the world. It's been 15 years in research and development, and just in the last month or so, we've finally gotten it to the point where we're ready to announce it to the world. So we're really excited and about what it can do for so many people around the world. And we're very honored to be joining you today, Bernd. So thank you so much for having us.
Thank you. This sounds wonderful. A very nice story, almost like a Hollywood story. Maybe it will be. Maybe.
Sometimes.
Sorry, Robert. I interrupted you.
I'm Robert Holcomb, and I'm also not an engineer. I was actually trained as a medical research scientist with a bachelor's and master's degree in microbiology, and then PhD in pharmacology, an MD degree, and a couple of residencies. So I was set to do medicine and medical research, and did that for many years in the medical center here in the United States. But I was raised in a family of electricians, motor winders, generator rebuilders, air conditioning, refrigeration. So before I went off to university, I was doing a lot of that during my summers, et cetera. So I learned a lot there, and I always thought that the electric power generator was very deficient in many of its design characteristics. So I had this driving urge to do something about it. I thought that we could generate energy much more efficiently by redesigning that generator. That's subsequently what I did. Over the past 15 years, as Ellen said, we have aggressively pursued that dream, and now we have a series of units or embodiments of this technology. That's why we call it Holcomb Energy Systems. It's not one unit, not one machine. We have an inline power generator that will take power from the grid and magnify true power by 500%. And we also have a standalone self-sustaining generator that is totally off the grid. It requires no power from the grid to operate it. And the building we're sitting in for this interview today is actually powered by one of the inline power generators. We've dramatically reduced our energy bill. It's been powering this building now for over 3 months continuously. So the technology is really sound. It's ready to go to market. We've been in R&D for better part of 15 years with no announcements. Not even our building had for rent signs on it. So we've been very quiet and under the radar that period of time. And now we're ready to take it to the world.
That's a wise decision, I would say. Yeah. So.
Yeah.
So this is also a very interesting story because, as I understand, you come from medicine and not from engineering.
I'm not an engineer by training. I'm an engineer. My dad taught me early on, and then I've been studying a lot for the last 15 years to get where we are.
Okay, fine. So this is really interesting, and I think you have a system to save energy, and there are a few machines involved, a generator and some others. But the implication is that you now have you run a small industry building for your research and business. So you powered it with this system during the winter, more or less. Huh?
Yeah, we've powered it for over 3 months now, and we have an additional building some short distance from this building owned by another party, and we have 2 of the units there powering that building. So we have some others in other locations as well that are being installed. So we're in that transition from research and development to commercialization, and our business model is joint ventures. We want to do joint ventures all over the world with people who need the technology and would like to help commercialize it. And we're negotiating some of those joint ventures currently.
Yeah, this sounds very interesting because, whatever helps. Yeah, if you had a system where we could save 25% of energy in Europe, I would say, give me the black box and then we use it in the industry. But now you can save much more than 25%, as I understand. So of course you have invented it, and you need financial power to roll it out. So cooperation is the most efficient model, maybe, to get it outrolled as soon as possible. And I can say one thing: we need it in the industry in Europe because energy supply is our big problem right now. We don't have so many natural resources in the Central European part. A lot has been bought from Russia in the past, and we see the implications or the results of it, and we need a change. And any way to alternative energy supplies could be very useful, and to save energy is also a big step in this direction. So I'm very happy that we are able to talk to you about it. So that means if we would apply the system to Europe, we would need a cooperation partner for you. What kind of companies are these? Is this energy companies? Is this machinery installation? Or how would you see this business model?
I think the model in general is joint venture arrangements with someone in industry who can contribute to manufacture, sales, distribution, and maintenance. Some of them are end users that we're negotiating with. Now, some are energy companies, and some are companies that would do manufacturing. There's many ways to do manufacturing: do in-house manufacturing, do contract manufacturing.
Yeah.
So the opportunities are really varied and many all over the world, because these units are really robust. They're not some fragile thing that has to be pampered. They can be installed in electrical substations, in air conditioner units, on homes, anywhere you want to decrease your energy bill, and you can actually series them so that you could continue to bump that energy intake, that 20% that you're still having to the grid. You can continue to bump it down. Say, for instance, if you had one on a business, and reduce the energy intake by 80%, and then you do the same thing on your air conditioning system, you can bump it another 80% down.
Mhm.
It's very, very flexible technology.
Yeah.
In parts of the world who not as fortunate as even the US or Europe, where energy is not available, we have the standalone self-sustaining unit that is applicable in those locations.
I would also say that since our unit has no moving parts, it runs totally silent. It makes no sound. And as Robert said, it's scalable everywhere electricity is needed. Although it's complex in design, it's quite straightforward to manufacture. And again, because it has no moving parts, it requires very, very little maintenance.
Mm.
It produces no heat. It runs at room temperature. So very little maintenance is required.
And
Yeah.
just for the information of your audience today, these units have been witness verified by the leading witness verification firms in the world. So more than one. So
Okay.
it's a really solid technology, and it's ready to go to market.
Mm-hmm. We will come to that, in a minute. Yeah, but you said something very important, because you said you can run these machines on room temperature, and they're very silent, because today generators or machines in general, they have to be in-housed, and then you you use a part of the energy to cool down the machine again. So that's a bit, it's a bit wasting of energy. So what you said, you could then install a generator in a big building, and you don't need to have so many let's say preparations for making it sound improved and to get away of the heat.
No, it's really not an issue.
Yeah. So this is wonderful news. Yeah. And as you said, for the machinery, you need a kind of companies who are used or who are able to build electrical machinery generators, and so they have to get used to your system. But apart from that, that would be the solution. Huh?
It's a true redesign of the generator we've known ever since Faraday developed the first generator. But it's been significantly redesigned to take some of the flaws and problems out of the generator. And then we initially did that with a rotary unit, and then I saw an opportunity to actually go solid state, and we did that, and it works really great.
Okay. Okay, and you said you already achieved some approvals and confirmations from leading companies. Can you maybe tell us also about that?
The two leading witness verification firms in the world have witness verified the data and the machines in operation. So that's true third-party verification.
Yeah.
And so these the units, and the biggest verification is they're running our building, running other buildings, and we're installing them in other locations. So the fact that you can install it in your location, and a month later you get your energy bill, and it's dramatically reduced. When we first installed the unit here, when we were in the early stages with it, the power consumption here was, on a cost basis, was approximately $1,500 US a month, and it dropped to something like $419 the first month.
That's a good result, I would say. Yeah.
So I mean, it's the proof is multiple. We prove it with the greatest techniques that are available to the field today, and witness verified by independents multiple times, as well as you put it on your building, your power consumption, power bill goes down.
But not only does your power bill go down, your carbon emissions go down at the same rate, right? So what's so exciting about this on a worldwide basis is we can really leap past the goals of the Paris Climate Accord and really reduce our carbon emissions significantly overnight if this were to be deployed everywhere, very, very quickly. So we can really give the planet time and room to heal itself. So it's good for us. Obviously, it's good for the company. It's good for the end user, but it's also good for the planet and the species that share it with us.
This is a very nice mission on which we are on. Okay, I think it's a good development, and many companies are also they are obliged to reduce their carbon footprint because they have to prove it to the end customers, and end customers in Europe, for example, get more and more aware of this sustainable issues, and they expect also the industry to save energy and to save resources. I think it could be a part, according to my feeling, could be a bit ahead to US or China, but the end users here, they get really aware of it and they really get sensitive to these issues. So you are right in time with your system, I would say. Yeah,
we're anxious to move it around the world. It was somewhat of a challenge to invent it when all the scientific world said it was impossible. But the biggest challenge is getting it out to the end user so that it can go to the benefit of the planet.
Yeah. Okay. This is a standard a standard pattern in development and science that everybody said it's impossible as long as somebody says didn't know about it or didn't want to know.
Exactly. It's impossible until somebody does it, right?
Exactly. And as you explained to us, you're coming from the medicine field, so maybe it's an advantage, because you don't understand maybe or don't want to know about all these restrictions, but you understand the big picture, the big picture of energy, the helicopter view or however you call it. So
I didn't understand. I couldn't do it.
Okay, so as it sounds for me, it's you are in a very, let's say, developed stage. So what could be the timeline to implement it in other countries or other areas as Europe? And I mean, we have to really also consider that we have a different, let's say, legal rules here and other rules. We have a different voltage in Europe than in US. So there is a bit know-how what we would need to put it in, But what is your timeline or what is your expectations to
the real series of events I believe that has to take place to do what we ultimately want to do is business arrangements with major companies in the countries of the world, and Europe is the prime point of interest for us. And then manufacturing and distribution of the units. But the units will work on 50 hertz, 60 hertz, actually up to the military frequencies, higher frequencies. So it's a very flexible machine. We can, and we've had these units field stamped to meet Underwriters Laboratories standards and National Electric Code standards here in the U.S., and we're having them verified and certified to European standards as well. So it'll be a ship and install when it's time, and the installation is fairly rapid.
Yeah, and I mean in Europe the situation is very similar from country to country. So if you got it ready at one, you will have all the area. We'll have the whole area.
Yeah, it's going to be a growth process, but we would like for that process to proceed rapidly. And so we're aggressively seeking joint venture partners now, and which, the bottom line is a unit must be, you have to have a business structure to do it, manufacture them, sell them, distribute them, and maintain them. Now, maintenance is very, very limited. The way they're built, they have about the same maintenance requirements as a transformer. So they're not a transformer, but the maintenance requirements are very similar. So you don't have to do much maintenance for a transformer. It sits there and operates for years and years, 20, 30 years or more.
Yeah.
So it's a technology that can be deployed very rapidly. We just need to get we've got a lot of talent in this world, and we don't want to reinvent the wheel, so to speak. We want to get people that are already in the field doing what we've developed and help us get it out there. So
Yeah. So you don't want to reinvent the wheel. You want to get power supply to the people.
that's right.
And reduce the carbon footprint. Yeah. So yeah, it's only good news from you. Is there any disadvantage? I don't understand. If the
I think the disadvantage is going through that transition of disbelief to acceptance. All new technology goes through that, though, all the way back throughout history. It's no different. And everyone gains. I don't think there's any losers by using this technology, because there'll be a transition from current methods to this method, and then there'll be a blending of some of the current methods. For instance, solar and wind, we can put these units on a solar field and increase the output by 400 or 500%, and not do anything else to the solar field. You don't have to put in 500% more solar operation. Just put this on the output of the solar field. Put it on the output of a wind farm. So you can get out the same power and cut the amount of infrastructure you have to build by 500%.
Yeah. I mean, we have already developed several alternative sources, as you said, wind power, and so we have quite a lot of it in Europe. So then let's say the part of it could raise, because you need less of other industry. We have a discussion in Europe to restart the nuclear power stations here, which we have, let's say, more or less switched off during recent years. So it's a whole energy supply is a discussion.
Yeah, you could take a solar farm or a wind farm that put out a megawatt and increase that by 5 times without building any more infrastructure.
That will solve lots of problems.
I think distribution of these units in proper locations and distributions in a chain type arrangement, so that you get reduction and then another reduction would be quite interesting.
You could put them all along the power grid too. Put them in substations all along the power grid, for example, to boost power along transmission lines. And the thing that Robert set out to do with this technology is really to make it more profitable to be clean than dirty. So this technology is far less expensive than any other technology in the marketplace today, including fossil fuels. So we want to bring energy companies of all types into the family with us. We want to work with them and bring everybody's costs down, bring their costs for production down, and also bring costs down to the end user.
The fuel cost and carbon footprint goes down.
Yeah. And I mean, it's also one thing I see at the moment, because I would say you are very at the beginning, in the early stage of the whole system, And I mean, I'm an engineer myself, but I would say if you give it to engineers, they maybe don't believe it in the beginning, but when they start to work on it, you get small steps of improvement every time, and you can even increase the efficiency of the system.
I think
no doubt,
I think that's very true. And
we've experienced that.
The self-sustaining unit has applications in different markets around the world where they're not fortunate enough to have any electric power.
Yeah. Okay. This is very good news. I thank you. Is there something you would tell our audience, last message or conclusion? Or
I would just say, if I could just jump in, I think that our greatest enemy is time. because, with the situation, we see what the situation is in Europe right now with the war, with fighting over a pipeline, with soaring energy costs, and the situation globally with climate change. Our biggest enemy is the passage of time. We humans on this planet and the planet itself don't have forever to wait. We need to deploy this technology now, and we need allies to do that. So,
yeah, I think my message would be, get involved with helping us. Either contacts companies that are interested in joint ventures, people who know of companies that are interested in joint ventures. But this will go around the world by the help of people. People in the world get everything done. If you don't have input of people, you can have the best technology in the world and it goes nowhere.
It's a question of people and mindset. Yeah, so
yeah.
Okay.
There's hope for the planet. There's a better world.
Yeah. I thank you very much for the interview. It was very interesting, and we are good in time for this time. Maybe we do it again more in detail. And I thank you very much for joining me. And please spare some minutes with me after the interview. And I think it's thank you for now.
Thank you so much. We really enjoyed it. Thank you for having us.
Yeah, thank you.
Bye-bye.